So the last part of section 38 is taking any ordinary function and creating the absolute value of that function. So if you notice, we have this graph of f of x, which is a parabola, okay? So we have this graph of a parabola, and we want to take the absolute value of that parabola. So we don't know anything about the function, okay? We don't know if it's x squared plus something plus something. We don't know what that is. All I know is that, remember parabolas, they have two zeros, which means that it always starts with x squared, right? X squared is always a parabola, how we write a parabola. So we don't really know what's going on here. We could if we applied the transformations, the translations that we talked about earlier. But basically, what we're going to do is we're going to take the absolute value of that. So for absolute values, every single time that you plug in a number into an absolute value, so when you plug in a number, that's always your input, that's x. The number that you get out is always positive. So whatever you plug in, your output is always positive. If you're wondering what an output is, your output is y. Well, if you notice on the graph, right, if we have an x, y graph, the output being, if it has to be positive, that means that all of these negatives, these negative y's, have to be flipped up top. They have to be positive. So this entire region, this whole region needs to be flipped up top. Okay, so wondering how do we start? You're always going to start with graphing. So go ahead and graph the zeros. You don't always have to start there. You can. You can start with the zeros, right? We graph the x-intercepts. If you want, you can start with the vertex, but you do have to graph the vertex. So for the vertex, the original vertex is at -2, -8. And when you plug in, all right, when you plug in the number, you plug in your x. X isn't positive or negative. It could be either one. X can be positive or negative. The output is always going to be positive, though. So the output in an ordered pair is always y. So what you're going to do is you're going to graph -2, 8. Then I'm just going to pick some ordinary points, all right, somewhere in this highlighted region, somewhere that I need to flip up top. So I'm going to pick -4, -6, and then I can also I picked 0, -6. I picked these 2 points because they intercept with the grid perfectly. All right, so anytime that we are doing this, we're changing the output, we're changing the y. So we're going to keep x, change y, keep x, change y. All right. So we're really close. So right now we're going to go down and we're going to touch the zeros. We're going to touch the x-intercepts or the horizontal intercepts. And from there, notice that we just have these 2 lines right next to it, okay? The 2 lines that are not highlighted. So from there, you just have to go ahead and draw your lines up, and that's your graph, okay? If you want to find like perfect interception points and then graph that, you can. All right, I did. Well, I didn't initially, but my graph was perfect, okay? Let's try again. So we have another parabola. This one it's facing downwards, which means that we'd have some sort of negative sign in front of the x squared. But you don't need to know that right now. All that we need to know is that we need to take the absolute value of this parabola, so anything in this region, but then we have to translate it down 3. Right, so that my subtraction of 3, that's k, right? K is away from or outside of the absolute value. So we're gonna move it down 3. So I'm just gonna start by graphing, plotting my vertex. So my original vertex is at 0, 5, but we have to move it down 3. 1, 2, 3. So I'm just gonna count down 3. All right, then we had these zeros. We don't have to move it anywhere, right? We don't have to move it up because it's already up. We just have to move it down 3. So we're not reflecting up, we're just moving it, we're just translating it down 3. 1, 2, 3. All right. Then what we need to do is we need to take this, and we need to flip it above. So we can find, I like to find perfect interception with the grid. It looks like it's going to be at -7, -5, and then we have +7, -5. You're only flipping your output. It's the only thing that you're changing. So when we do that, you're going to get -7, +5. And then we get +7, +5. But then we have to move down 3. So this is where we start. Move down 1, 2, 3. This is where we're going to put a point. Same thing on the other side. So we start at 7, 5, and then we have to move down 1, 2, 3. So we are going to make our parabola, and then we're going to shoot up from there. And this is our final answer. This is our graph. So first we reflected up, and then we were able to go down 3 based on the translation. You can go ahead and try the exit flip. So this is a combination of all 3 videos of section 38. So we were writing a piecewise function, we were solving for x, and then we were translating. So I'm going to go ahead and pause. You can go ahead and pause the video, and then in a second, you'll see the answers.